I'm Dan, and my relation with building solutions for mHealth has been increased in the last year heavily because of the COVID-19 crisis. And the story I'm going to tell you is how do you actually have to lay proper fundamentals for building such systems. And the illustrative case I will be using will be the COVID-19 contact tracing mobile app. So with any luck, you will be seeing my screen, and that is the case.
Perfect.
So my take-home message for today is that reusable and secure service infrastructures means that you can build e-health, mHealth, or whatever kind of new services quickly, for when the time comes, you may not be able to build them in time. So my story for today will focus on the COVID-19 testing and notification infrastructure at work in Estonia. The first part I'm going to focus on is the critical one, the testing. How do test results get to the person? And in Estonia, what we have put in place is an electronic health record system that is a national one. It is a part of the whole reimbursement system, so that when a medical agency wants to have its costs covered by the payer, then the data about this transaction will need to reach the electronic health record, which is basically partially managed by the payer. So the good thing is that all test results for COVID-19 tests, the PCR tests, reach the electronic health record of the individual. And this is done over the Estonian e-government backbone called the X-Road. The X-Road system is a distributed system that has multiple servers, multiple nodes, and no significant centralized components, meaning that there is no super database of everything. There is no, the tax information and the healthcare information are in no single system. Instead, the diagram of the system looks something like this picture. The bigger red circles are the bigger systems, like the population registry and the education registry and the vehicle registry and so on. And the smaller systems are the customers. Services like if there's a police car on the highway and they pull over a speeding car, then while in their patrol vehicle, they can key in the license plate number for the car they have stopped. And before the police officer exits the patrol car and goes to discuss things with the car they stopped, they can make a query whether any of the registered owners of the car has a registered firearm, a weapon. So this is not, again, in a central database. Multiple queries are made over a similar network. And this network has also been used for e-health data exchange and the COVID-19 test information exchange. So it's done on end-to-end encrypted channels, authenticated, digitally signed, so transactions on the system can be usable as evidence in court when needed according to the law. So this means that test results are not lost. This service also allows people to be noticed about their test results over SMS, mobile messages, or email, but they are also collected so that they can be used to produce further services. And this includes foreigners, people who are not citizens. And why is this important? Because in the early days, when we had this crisis, then people wanted to know what their test results were. So very quickly, we could put in place a new service, which was in the patient portal, which is also available based on all the data I have in the health record. There was this new button was added to that, which was the coronavirus analysis lab results. And because this was what was on everybody's mind, this was a service that the patient portal needed. It was something new and had to be done quickly. So this service was put in place in a few weeks because the health record already existed. The data was there. So you only had to add a new big red button, which you see on the left side of the screen. And it used the data available to provide you with your results. Now, the second question is, how does the system know that it is you? And the answer to that is on the right side. Estonia has multiple national digital identity platforms, which means that if something happens with one of them, you can use the other still. You don't have to go back to riding horseback if your car breaks down. It's a good analogy, I think. So when I go and log in to my patient portal account, I have to prove it's me using strong authentication. Strong meaning that it's all eIDAS regulation compliant, strong levels, high levels of assurance according to that. So we have three technologies. One is the ID card, which is a smart card using a chip. Mobile ID uses a chip on a SIM card. And then smart ID is the most innovative of the three, where keys are distributed using threshold cryptography. And then never reconstructed once you want to prove your identity or give digital signatures. The latter two are usable on mobile phones, which makes them especially good for mHealth applications because I can do everything on my mobile phone. Same way I can use the same ID technology for online banking or mobile banking, I can also use it for mobile healthcare. So digital signatures and remote access are greatly supportive of all kinds of remote work. So this is something that was very useful. So in 2020, the crisis hit, and very quickly we could build a new mobile health service where you could log into the patient portal using your mobile device and then click the button and get your test results, get the test data for yourself. And there were actually further services quickly built because the health informatics agency also built services to quickly get the sick leave documents registered because people couldn't go to their family doctors, the general practitioners. And there were various other over 5 different services built quickly on top of the fundamentals of secure authentication and the eHealth record. And as the last part, the contact tracing app that Estonia is using also needs information about who has been tested positive. So the Estonian contact tracing app called HOIA, again, it follows the blueprint that many European countries have, where you have a mobile application which has a secret key for each day. And then over Bluetooth channels every day, random identifiers are exchanged and stored. So when I stay within somebody's 2-meter range for 15 minutes, then I will have from them one of the pseudonymous keys that they have been distributing. If one of the people gets a fever, they suspect they have COVID, then they can get tested. And then if they get their test results, they know that they're infected, then they can authenticate themselves to the patient portal, much like I described before. And if the patient portal confirms the test results, then this confirmation will go to the contact tracing system backend, where the patient will then upload their secret key for that day. This secret key will then be downloaded by all the other users of the contact tracing system, and only those who can match the key with one of the random codes will get a notification. The backend service will not get the information on how many people are notified, and it provides privacy to the best possible way. The backend system does not also know about all the people's queries to the patient portal and so on. It's a very distributed, very tightly engineered to ensure that each part of the system knows just exactly as much as they need. So the system is built on the same Google Apple exposure notification API that has been used heavily in the rest of Europe. And the distributed privacy preserving proximity tracing project from EPFL in Switzerland. And the key difference in many countries and Estonia is that in many countries, the codes are being used. Once you test positive, you receive a code which you can put in your app and then to confirm that you're ill. The problem is that in many countries, according to the studies that I have read, the distribution of codes is not very efficient, but not everybody who has a positive test receives the code. And that has been a reason why contact tracing on mobile phones has not been as efficient as has been hoped. So the Estonian version ensures that everybody who has been testing is technically viable, eligible to enter their diagnosis in the contact tracing app. The main bottleneck for us is the availability of this strong authentication, which unfortunately, but fortunately has a pretty good rollout. It's not available for kids under 13. And for them, we are also considering building the code-based system, but the legal aspects of that are still being studied. So this was an example of how the existence of these fundamental services built early on allowed us to quickly adapt and build new services for mobile health, contact tracing, and reimbursement of sick days and so on. So I strongly support the development of secure infrastructures everywhere. Thank you.